So before I even start on my talk, I have a question for you, which is how many things are wrong with this design? And this is a contact with a first name, an initial and last name, and an email address, and some sort of flag, which is supposed to be set to true if you have clicked on the verification email that you got, and so on. Now, if you saw this in a code review, would you think it was okay, or would you say this is terrible? And if it is terrible, what would you do to improve it? Now, to be honest, I used to be fine with this kind of stuff, but I've learned new ways of doing things, and I'm going to share that with you today. And hopefully, you'll see by the end of the talk, you'll see a completely different way of doing this model. So this is domain modeling made functional. I'm Scott Wlaschin. I have a website, F# for Fun and Profit, which is all about F#, as you can probably guess. So this talk is about the intersection between functional programming and domain-driven design. Not a lot of people are in this kind of intersection. I think it's really powerful, but a lot of people are put off because they think functional programming is scary, because there's all these words, functor and applicative and monoid and monad. And you think functional programming is not for me. It's too weird. Here's Homer being freaked out by functional programming. Now, it's not that it's scary. It's unfamiliar. That's the thing. If the words were something different, if they were mappable or collapsible or chainable or something like that, here's Homer. He's still puzzled by what the words mean, but he's not freaked out by them. And I think that's one of the problems with the functional programming community is there's a lot of mathematical jargon. But don't let that put you off. It's actually, a lot of this stuff is not as hard as you might think it is. I'll tell you what's really scary is object-oriented programming. It's like there's all this jargon. There's polymorphism and inheritance and interface and covert, and there's solid. And solid is 5 other things, and each of those is an abbreviation. And there's IOC and DI and ABC and MVC. Object-oriented programming is also really scary, but you don't think of it as scary because you know all the jargon. So, if you're a newcomer, you think it's just as bad. So don't be put off by the jargon. It's not as bad as you think. So the good thing is you don't need to know any of this stuff. YAGNI for all this stuff. YAGNI on monads for this talk. I'm not going to be talking about monads at all. People think that functional programming is really good for academic stuff or parallel processing or something. It is good for that, but it's actually really, really good for boring line of business applications. I call these blobbers. And this is what most of us do all day. It's like accounting, inventory management, e-commerce, that kind of stuff, boring stuff that used to be done in COBOL. And actually, I think functional programming is actually really, really good for that. And I'm going to take this boring example of a contact and show you how much fun it can be. So functional programming and domain-driven design, I actually think go together really well, even though you might not think so at the beginning. So let's start off by my take on domain-driven design and why I think it's so important. So I like to think of the software development process as a process. There's an input and you do something and there's an output. And we love to talk about process as developers. We talk about what's our favorite languages, our favorite tooling, our favorite editors, test-driven development, continuous integration, all that stuff. It's fine, but coding and testing is actually not the most important part of development. I actually think that the problem is if you have garbage in to your process, you will have garbage out. Even if you're using the best programming language and you have the best programmers and everything, blah, blah, blah. If you have garbage coming, you have bad requirements or misunderstood requirements, you're going to have a bad output. The best tooling in the world will not help you there. So that if you can reduce the garbage in, you can reduce the garbage out. That's the goal. And that's, to me, what design is, getting the requirements and the modeling right. And that's, I think, why we're all here at this conference. So how can we do design right? So not coding, but design. So I'm going to take something away from Agile. So the big thing from Agile is rapid feedback in my book. It's all about how learning quickly, putting something out there, getting feedback on it as fast as possible. Now, we normally think of that in terms of coding, but you can equally well do that in terms of design. And then the big contribution from domain-driven design is that people have a shared mental model. And that shared mental model is shared by everybody, including the code. So, you have the developers have a model, the product owners have a model, the users have a model, but the code also represents that model. So this, to me, is sort of domain-driven design in a nutshell. So here's a little picture of all the different people, the stakeholders or whatever. They all have this shared mental model, and notice that the code is part of it. So there's this common language that everyone uses, the ubiquitous language, the whatever. But to me, having the code represent that is the most important part. If the code represents the domain model, then other developers come on board, can look at the code, and they become hopefully they become sort of domain experts. And you don't need, if you have a nice domain modeling code, you don't need a lot of documentation in the same way. So here is the problem. Can you make the code look like the domain? And this is what non-developers think source code looks like. And actually, this is what some C programmers think source code looks like. So I'll tell you what I think source code, this is what domain-driven source code should look like, okay? Now, you have to guess what this domain is, okay? And I'll give you like 30 seconds to guess what the domain is, right? So yeah, I think it's pretty obvious. It's something to do with game of cards. And we have our shared language, our ubiquitous language down the side, and the card game is the bounded contexts. So, this is what I'm talking about. This is the kind of code I'm talking about. And the way I explain this to non-developers, this is actually F# code. And for people who don't know F#, the vertical bar is a choice, like a club or a diamond or a spade or heart. A little asterisk means a pair, so a card is a suit and a rank. We have list types are built into F#. And finally, at the bottom, we have these deals and pickup card, and there's a little arrow, and that means it's a function. And I use those to represent workflows or stories or scenarios or whatever, and there's an input and output. So let me explain that a bit more. Functional approach to domain modeling is to have the verbs or the actions be represented as functions. So here's the deal function, and the input to the deal function is a deck of cards. And the output is a card on the table and a different deck of cards, because in functional programming, everything is immutable. So you don't mutate the original deck. You make a clone of that deck, and you remove the card that you dealt. So the original deck is unchanged. So we say in functional programming, we'd say this is a deal, and the input is a deck, and the output is a pair of a deck and a card. And if we want to do something, how do we model like picking up a card off the table? Well, I have my hand, and there's a card on the table. That's the input. And after I've picked up the card on the table, that's not there anymore, and I have a new hand with the new card in it. And we would write this as the input is a pair of the hand and the card, and the output is the hand. So there you go. That's everything you need to know about functional domain modeling right there. So here's our domain. Do you think this is a reasonable amount of code to write for this domain? I think so. It's like basically everything fits on one page. That's pretty impressive. Now, this is a pretty simple domain, but in my experience, even more complex domains fit on like 3 or 4 pages. And that's quite nice. Do you think a non-programmer could understand this? And I think the answer is yes. I've actually done modeling workshops where I've had developers and product owners and domain experts all in the same room, and we're typing this code on the screen. And, they say, this is great. In fact, one comment I had was, this is great, where's the code? You said we'd be writing code, where is it? So this is actually code right here. Do you think non-programmers can provide useful feedback? There is actually a deliberate mistake. Can anyone spot what the deliberate mistake? Yes, it's pretty obvious that this ace is missing. Now, you don't have to be a programmer to notice that. And again, I'm using a very trivial example, but in more complex examples, the domain expert would say, hey, you forgot this important situation that I haven't handled before. So that's good. So this thing of getting rapid feedback, again, I think is really, really important. Now, in Agile model, the idea is you don't deliver something 6 months from now, you try and deliver something this week, or in a couple of days, you get as much feedback as possible, as early as possible, which is great. But what happens if you get feedback in minutes rather than days? So when I'm doing a domain modeling session, and I'm typing stuff on the screen, and the domain experts are looking at it, they often give me really good feedback. For example, I'm typing along, And I say, to deal, you start with a deck of cards, and so on. And the domain expert might say, that deck thing, that's actually not right. When we deal, we use a shuffle deck. And, oh, okay, a shuffle deck, what's that? So, so you deal with a shuffle deck instead, is that right? And they say, yeah, that's right. So we now have the deal function is working with these things called shuffle decks. So this is a new concept. I didn't realize there was a whole thing called a shuffle deck. So I say, what is a shuffle deck? And, well, it's a list of cards. So I add a new concept to the domain called a shuffle deck. Now, what I do not do is add a flag to the original deck saying, is it shuffled or not? Okay, that's not how it goes. It's a different concept. Shuffle decks are different from normal decks. They can't be used interchangeably. And then I say, well, okay, where do you get this shuffle deck thing from? Like, how do I make one of these things? And they say, well, you shuffle a deck, duh. It's like, because when I'm doing domain modeling, I ask lots of stupid questions because I'm not a domain expert. So I ask them, and they know this stuff inside out, and they say, well, obviously you shuffle decks. Everyone knows that, So yes, I'm going to write that down. I'm going to document it. To take a deck to a shuffle deck, you have a special thing called a shuffle. So there's an example of the domain modeling kind of evolving, okay? And it's happening interactively. It's happening in a few minutes, rather than we don't have to wait a couple of weeks to find out there was a problem. So here's our final version, with this new shuffled deck thing. And this is why I call it domain-driven, because there's nothing in here about implementation. There's nothing about databases, for example. There's nothing about foreign keys, joins. This is what Eric calls persistence ignorance. Now, at some point, you may need to put this stuff in a database. That's true, but that's not part of the domain. That's something else you have to do, but it's not part of the core domain. It's not object-oriented either. There's no base classes. There's no managers. There's no factories. There's no all that stuff. I mean, what you want to do, in the real world, you have this vocabulary. And in your code, you want to have the same vocabulary. And, it should be in sync. And if the real world changes, let's say you discover this thing called a shuffle, you learn about this new concept in the real world, you put that in the code. You now have a new concept in the code called a shuffle deck. Right. So that's the right way of doing it. And what we shouldn't do is the other way around, where the domain contains programmer jargon, something that domain experts do not understand. So you don't have to have a player manager for managing the players. That's not something in the domain. Let's say, oh, well, shuffle deck and a normal deck have something in common, so let's create a base class for them. No, that's not part of the domain. You do not have an abstract card proxy factory bean. These things are not domain concepts. Now, when you come to implementing it, yes, of course, the implementation gets a bit gnarly, and you might have to have these things, but that's in the implementation side of things. That's not in the domain modeling side of things. Okay, so that's bad. All right, so here's our domain. Again, the design is the code, and the code is the design. That's one of the agile goals as well. You can't trust documentation that goes out of date. The source of truth is the code. So if you can have code which is nice and easy to read, that becomes the source of truth. And in a typical F# project, this is like the first file in the project, and all the other files relate to this file. This is the kind of definition of all the interfaces that they have to implement. And of course, this is not pseudocode. This is executable code. And another thing is it's not about, the result of doing this. A lot of it is actually the process of getting everyone in a room. Just like event storming and context mapping and all these things, the process of getting everyone in the same room and talking about it is actually a really important part. So it's not just the idea is you don't come out with a document and say, this is the answer. Getting everyone to agree, having these debates and having these interactions and stuff is a really critical part of the process. So, don't focus on the output, also focus on how you get there. So, we have our key domain-driven principle, which is communicate the design and the code, just like I did with the card game. So here we have the example I gave at the beginning, and now I can say, does this communicate the design? And the answer is no. Because, for example, which values are optional? Like the middle initial might be optional, but the first name might be required. That's not communicated here. It might be some validation logic somewhere, but it's not here. So what I want to do is say, well, the middle initial has to be optional. How can I communicate that? There are always constraints. Can the first name be 1 million characters long? Can it contain non-printable characters? Can it contain line feeds? it's not at all obvious. Now, again, I might have some validation logic somewhere, but that's not communicated. We want to communicate it right here. So, for example, if you're going to stick it in a database at some point, you might have to say, well, it has to be less than 50 characters, right? And we want to actually represent that in the code. Which fields are linked. So if one person changes the first name, another person changes the last name, that's a concurrency error probably. But that's not communicated here. We want to make sure these things are, which are the atomic units of update. So this is an atomic unit and that's an atomic unit. What else? Oh yeah, what's the domain logic? We have this Boolean flag. And when is it supposed to be true and when is it supposed to be false? And the wrong answer is, we'll go and look it up in the comments, or go and look it up in the 200-page spec. We don't want to do that. We want to represent the model in the code. And in this case, if you have a new email, you have to set it to false. And you can only set it to true when you click the verification link. Right? But that's not at all clear from here. So this is a bad code because it does not communicate design decisions. So all these things, functional domain modeling can communicate these decisions. And by the end of this talk, I think you'll see how I can do it. Right, so part 2 is, before I can tell you how I want to do it, I'm going to give you a little bit of functional programming background. Okay, and I'm going to use some jargon. So this is something called algebraic types. Okay, now that's a bit of math jargon. So a much nicer, more friendly word is to call them composable types. Okay, composable, that's something I can understand. So if you're coming from OO, the first thing to know is that types are not classes. They're more like sets, okay? So let's go back to the definition of a function. A function is something that turns inputs into outputs. That's like your high school algebra, right? Here's my function, and I like to use like railroad tracks as my model for functions. There's a little tunnel of transformation. Something goes in the tunnel, like an apple, and it comes out as a banana. So this is my prototypical function. And we write this as an apple, arrow, banana. So the input is an apple, and the output is a banana. Okay, that's everything you need to know about functions. So what about types? What is a type? If it's not a class, what is it? So a type in functional programming is just a name for a set of things. That's it. So all the valid inputs, all the valid outputs, you give these names. So if I have all the numbers that could be possibly used, to pass in, we'll call that type integer. All the possible strings that you can spit out, we'll call that type string. All the possible people that you can pass in, we'll call that type person. All the possible fruit that you can, return, we'll call these type fruit. Okay. Now, because they're sets, you can have anything in these sets. In particular, you can have functions, a set of functions. So this is a set of functions that are fruit-to-fruit functions. These are functions that turn fruit into fruit. So, functional programming, one of the reasons it's kind of complicated is you often have functions that take functions as input and spit functions out as output. And that's where your brain starts to hurt. But the fundamental principles are pretty straightforward. Okay, another big principle of functional programming is composition. You'll hear this word everywhere for everything. Functional programmers love to talk about composition. Composition is like Legos. If you know how to use Legos, you know how to do composition. So, if you think about Legos, the pieces are designed to be connected, right? They all have little bumps on them. You don't need special adapters. That's the way the Lego model is a compositional model. And the algebraic type system, which I like to call the composable type system, is the Lego version of types. Okay? And this is only possible because in functional programming, the data and the behavior are separate. So the reason you can work with sets of data is because there's no behavior. Now, if you have behavior, it's really hard to mush two objects together because we know what's supposed to happen. Now, if you come from OO, you'll probably say, well, this is an anemic domain model. This is a really bad thing. But in functional programming, it's actually a good thing. So you just have to trust me on that. Okay, so how do you do this composition? How do you connect? How do you compose types from other types? Well, you build big things from small things, just like the big bits of Lego from small bits of Lego. And there's two ways of doing it. You do and you do or. And I'm going to use these words liberally because when we talk about things, that's how we use these words. So anding. So let's say I want to model a fruit salad. I will say, well, I need an apple and a banana and a cherry. I'm using the word and. And something like a pair or a tuple or a record type. These are all the things, or struct, This is every programming language has this kind of thing. And in F# we write it like this. It kind of looks a little bit like JSON. There's a curly brace, and there's an apple, and a banana, and a cherry. There's basically 3 fields. But all 3 fields are required, right? None of them are optional. Now, the other way of composing things together is using OR. So if I want to model a snack, for example, I might say a snack is an apple or a banana or a cherry. And this is the kind of thing that's not available in most OO languages, but most functional languages have this. So in F# you'd write like this, use vertical bars. So this is a snack is an apple or a banana or a cherry. And the of is the extra information about what it is. You know, the extra information. If it's an apple, what kind of apple is it? If it's a banana, what kind of banana is it? So that's what I call these choice types. They're also called discriminated unions. They're also called sum types, co-product types, all sorts of words. But I like to use the word choice because that's how you think about it in domain modeling. So let's look at a real-world example of this kind of process of composing types into bigger types. So let's say you're doing a payment processing system, and you accept card, check, or cash, check, or card. And now for cash, there's no extra information. For checks, you need a check number. For credit cards, you need a card type and a card number and expiry date and all that other stuff. So how would you implement this? Just think for a second. How would you implement a card? 3 choices here. So I think in OO, you would probably have some sort of interface, like a payment method interface or an abstract base class or something. And then you have like 3 other classes that implement that interface. So the check, a cash class and a check class and a credit card class. And each class has the information it needs to do its work. So that's kind of the OO way of doing it. But let me show you a different way of doing it. In functional programming, we would normally do it another way. First of all, we start off by getting rid of the primitives. You don't use primitives in domain modeling. People don't talk about ints, they talk about check numbers. And they talk about card numbers. Right? So first of all, we get rid of those. And then we say, okay, a card type is a choice. It's Visa or MasterCard. And the credit card information is a card type and a card number. So I'm using or, and then I'm using and. So this is a choice using or, and that's a record using and. Okay? And we keep building up on top of that. We say, okay, our payment method is cash or check or card. So because it's or, it's a choice type. And again, there's different, each case has information associated with it. In the check case, we need the check number, and in the card case, we need the card info. Okay, we can keep going. Payment amounts. Instead of using the word decimal or float, we're going to talk about payment amounts in our domain. Currency, say, is dollars or euros. So that's another choice. And then finally, we can keep going and build a bigger type, a payment, say. So we say, to make a payment, you have an amount, and you have a currency, and you have a payment method. And. So that's an and type, or a record type. So what we've done is we've built a bigger type from a lot of smaller types, using composition, using Lego. So this is what I mean by composing types to make bigger types. And this is the technique we'll use throughout the rest of this talk. So you can see it's a very different way of thinking about representing domain models. And I think it's very cool. Okay, so a lot of people think of types as for type checking. Like I have add 1, and it's got an int, and it's give it an int and it adds 1 to the int. And the idea is the type or the class or whatever, it just stops you passing in a string by mistake. So the type checking is often, a lot of people find it an annoyance, especially when it's kind of very verbose. But I'm going to think of types as a domain modeling tool. So when I can say, to deal, you start with a deck and you spit out another deck and a new card. That's nothing to do with stopping me making mistakes. That's actually using it as a modeling tool. But what's cool is when you do this, you get both at once. So you define your sort of domain model, and then it gets type checked. So you can't accidentally pass, well, in this case, I'm using a deck. But if I change this to a shuffle deck, I couldn't accidentally pass a normal deck to a shuffle deck. The type checker wouldn't let me. So combining the domain modeling and the type checking is a really powerful technique. And I like to say that it's almost like having compile time unit tests. If you were using a dynamic language like Python or Ruby or something, you'd probably have to have, compile time, a runtime test, like make sure, or unit testing, make sure that you don't pass a normal deck into a shuffled deck. If you have a statically typed language, it won't compile. You don't have to write a unit test to stop it happening. So that's cool. All right, so statically type all the things. This is the way to go forward. Right. Domain modeling with composable types. So we've talked about how composable types work. Now let's take it out for a spin and see what we can do with it. So we're going to go back to the original issue with the challenge, and we're going to see how we can model it. So we're going to start with optional values first. Here is our original thing, and we say there's a middle initial, which is optional, right? But the first name is required. And as I said, I don't have to look somewhere else to figure out what the rules are. I want to actually look right here. So how can we represent optional values in the domain? I'm going to talk about why null is not the right answer. Let's say that you have a function that gets the length of a string. Okay, so the input set is all the possible strings, and the output set is all the possible ints. And here's my set of strings on the left-hand side, and here's the problem, which is null is in that set. So if I create a variable of type string and I assign null to it, the compiler's not going to complain. They say, yeah, fine, null's a string. But when I try and actually get the length of that, it's going to throw an exception and crash. So it's really, really bad. Null is like a traitor. Null pretends to be a string. The type checker says, yeah, that's a string, but when you actually try and do something with it, say, I'm not really a string, I'm just fooling you. So I like to use this thing, null is sort of the salmon of static typing. It's like someone who pretends to be your friend, pretends to be all good, but then they're going to turn around and stab you in the back. Okay? So do not use null anywhere. Okay, so let's not use null. Okay, so we're going to take null out of the allowed values. So how do we represent something which is missing? Well, if you think about how we would say it, there's a string or it's missing, or, right? So it's a choice. Either is one of the things in the set of strings, or it's missing, which is like the empty set. There's only one missing thing. So we're going to combine them, and we're going to give these a tag, something and nothing. So here we go. We're going to write a new type, which is a choice. It's a choice type between some string and nothing. And if it's some string, then there's a string in that case. And if there's nothing, there's no string. So we've modeled missing values just using the composable type system. We don't have to do it's not any special kind of built into the compiler. It's just a standard thing. So this is great. This is awesome. And you say, optional strings. Oh, and then we need optional ints as well. And also we need optional booleans and so on. And then after a while you say, actually, there's quite a lot of duplicate code here. Maybe we can get rid of that. And so you come up with this thing called an option, and it's a generic type. So this tick T is F# way of doing generics. So you have the angle brackets, just kind of like C# and Java, but the little tick tells you it's a generic type. And this type is built into F#, and it's built into most functional languages. But if it wasn't built in, you could write it yourself. It's 3 lines of code. So you don't, it's nothing special built into the compiler. It's just a way of modeling missing values. So once we've done that, we can go back to our name, and we can say, instead of it's just a string, it's an option of a string. And that's now very clear. And in F#, you can actually put the option at the end. You can say it's a string option, which is a little nicer to read. So now we've actually explicitly modeled in our domain what is required and what is optional. So in F#, if it's not optional, it is required. So these other 2 strings are required. So that's nice and readable. Okay, what about simple values and constrained values? So there's a classic thing, a good guideline, which is avoid primitive obsession. Do not use ints and floats and strings in your domain. That's not what people use. Don't model them with primitive types. I was once working on something, and I was talking about, is this a float? And they said, what do you mean a float? Is that something to do with water? So float means nothing to a domain. To the average non-developer, it means nothing. So don't use the word float. And on top of that, it's really unusual to have an unbounded value. Like, it really would be unusual to have a string that can be 1 million characters long. And it would be really unusual to have an int that can be 4 billion. Normally there's some sort of constraints. So for example, email addresses, you can't have a 1 million character email address. It's normally something, but certainly it can't be empty, and there's some sort of pattern, let's say it has to have an @ sign, something. If you have a customer ID, it's represented by an int in the database, but it has to maybe be a positive int. So email addresses are not strings, customer IDs are not ints. I mean, you can't multiply a customer ID by 5. Can you take the square root of a customer ID? It doesn't make any sense. They're not integers. Now, they may be represented by an integer, but they're not integers. So don't represent them by integers in your domain. So what we do in functional domain modeling is create wrapper types around these things. So here's an email wrapper type. Here's a customer ID wrapper type. So this is a wrapper around a string or a wrapper around an int. So they're no longer strings and ints. Right, wrapper string, wrapper int. So here's two wrapper types, an email address and a phone number. They both are represented by strings behind the scenes, but by doing these wrapper types, they are now distinct types, and they can't get mixed up. And they are very clearly different in the domain. Just like a shuffle deck and a normal deck are distinct concepts in the domain. They might have the same representation, but logically they're distinct. Here's a customer ID and an order ID. They're both represented by ints, but with the two wrappers around them, they are distinct types. So that's nice. So we do this a lot. And in fact, you saw me do it almost with a credit card number or the check number, that kind of thing. So this is great because it's a clearer domain model, and we're using words which are in the domain model. And from a debugging or from a code quality point of view, you can't accidentally mix them up. You can't ever pass an order ID to something that expects a customer ID or a phone number to something that's working with email addresses. So many, many benefits to doing this. And it's one line of code. So what's stopping you? All right, so let's say we have a constrained type like email, and it has to have an @ sign in it. How can we create one of these things? So here's our little thing. Here's our function called create email address, our factory method, if you want to call it. If the string contains an @ sign, then we take that string and we wrap it in the email address type. Okay, good. What happens if it doesn't contain that string? If it doesn't contain an @ sign? What should we do? Should we return null? No. Should we throw an exception? No. We want to model the fact that sometimes it works and sometimes it doesn't work. How can we model that? If you look at the signature, the function, it says you give me a string. The way it stands right now, it says you give me a string as input, and I guarantee to give you an email address as output. And that's a lie. That's not true. Sometimes I can't give you an email address. So we like to, in functional programming, we like to model things explicitly. So we're going to do it this way. We're going to use the option thing we just talked about. We're going to say if it's got an @ sign in it, then that's good, that's something. If it doesn't have an @ sign, I'm going to give you nothing. And if you look at the signature, this now says you give me a string, and I might give you back an email address, depending. So this is not a lie. This is something that's very explicit. Now, the person calling this now has to handle that situation. They can't just ignore it. But that's good. That stops bugs from happening. We do the same thing with the string 50. So instead of using a regular string, we're going to create a wrapper around it. And when we create the thing, we have to check the length. And if it's a valid length, we say it's something. And if it's not a valid length, we say it's nothing. And again, we have this helper function. You give me a string, and I might or might not give you a string 50 back. Now, typically, all this stuff is done at the boundary of your validation, at the edge of your bounded context when something's coming in from the outside world. And you do a lot of validation. But once you've got a valid email address or a valid string 50, you never have to check it ever again in your domain because it's immutable. Nobody can mess with it. So the hard part of the validation is always kind of nasty, but once you've got this thing, you never have to do any kind of defensive programming. It can never be null. It can never not have an @ sign in it. You only have to do it once at the edge of your bounded context. So this is really nice. Okay, here's another one. This is a shopping cart with 999,000 items in it. And this is probably a bug. This is very unlikely that you can actually go to Amazon and order, 1 million items. Chances are the developer used an int to model the order line quantity because they were lazy. And you get this kind of situations. I've heard of things where you actually get an overflow when it becomes like minus 32K or something. These things should never happen. So how can we stop that kind of thing happening? Well, we're going to create a new thing. Okay, we're going to create a special type which wraps an int, but it's called an order line quantity. And this order line quantity is a constrained type. Now, a lot of people probably wouldn't even bother. Like, to be honest, I probably wouldn't have bothered if I'm writing, PHP or something. Because it's a pain to write new types just for this one little thing. But if it's a one-liner, it's actually not so bad. So, if it's easy to do, you're much more likely to do it. And this communicates the fact that, the order line, for example, has to be between 1 and 99. You can't order more than 100 things on this website, but you also can't order 0 things. So you literally cannot represent a situation where there are 0 items. So here's our function, and you say, you give me an int, and I might give you back an order line quantity. Now, what happens if you have one of those decrement buttons, and you go down, 2, and then you say, take one away, that's 1, and you take one away, that's 0. You can't represent that. You can't have an order line quantity with 0 in it. So you are going to, as a developer, you are going to be forced to deal with a situation when it goes down to 0, because you can't just blithely ignore it and say, well, I'll deal with that later on. You literally will not have one of these things, so you literally cannot keep going. So it forces you to deal with these situations. So here's the contact challenge. We've done the string option, and we now have these constraint types, or these types which represent the domain better. And it's really easy to refactor. Again, because there's no behavior, we can take a big thing and split it into 2 smaller things. That's really easy to do. You don't need a special refactoring tool for that. And then we combine them. So we now have a personal name and an email contact, and then we combine them into the overall contact. Okay, so that's 3 out of the 4 things. But we haven't done this email verify flag yet. So let's look at this one. Here is our email contact information. There's an email address, and there's this Boolean flag. And there's some business rules associated with this Boolean flag. If the email is changed, that has to be set to false. And in addition to that, this flag can only be set by a special verification service. You click the link and it checks the hash and stuff. You shouldn't be able to change it to anything yourself. You should be forced to go through the verification service, because otherwise some malicious person can change it to true, and that's like a security hole. So there's the business rules. So one way to say, well, I'll just add some documentation, add some comments, and I'll do some verification. No, we're not going to do that. We're going to make sure that it literally can't happen. How can we make sure this literally can't happen? So this is bad because anyone can set it to true. So what we're going to do is create another type, another wrapper type. We're going to take the normal email address that we had, and we're going to wrap it in something else called a verified email. And this is the guideline here is there's no problem that can't be solved by wrapping it in another type. So yeah, we had a normal email. Now we have something called a verified email, which is not the same thing as a normal email because we've made a wrapper around it. And then we have our verification service, and that says you give me a normal email address and some sort of hash, and I will give you a verified email maybe, if the hash matches and if you've done it fast enough and so on. So this is very clear that this service might or might not work. Okay. Now, what are we going to do with this? We are going to replace that Boolean with a choice. So we're going to say the email contact information either uses an unverified email or a verified email. It's a choice between these 2 things. Right? Now, in the unverified case, you can use the information associated with that is a normal, any old email address. But in the verified case, it has to be one of these verified emails that we just talked about. All right? Where does one of these verified emails come from? Where do I get one of these things? I get it from the verification service. Right? So to create the verified case, you have to have a verified email. And you can't create the verified case with a normal email. So if I change my email and I want to create one of these 2 choices, I can only create the unverified choice. I cannot create the verified choice because I do not have a verified email to do it with. Where do I get one of these verified emails from? Right? I get it from the verification service. Right? And you can actually do it so it's like a private constructor so that nobody else can make this thing other than the service. And when you do it this way, you've actually guaranteed the business rules. Right? This thing that you can only verify through a verification service, and if it's a new email, it has to be set to unverified. We do not have to write unit tests for this. This is you cannot even write code where you set the verified flag with an unverified email. You literally cannot write the code. It will not compile. So there's no point even writing a unit test for it. So that's one thing. In addition, it's actually clearer to understand. The Boolean was very confusing. This is like right in your face. It's unverified or verified. So this is good. This is how we should do our domain modeling. So if we go back to our model, we started off with one thing, and we now have 6, 7 things that we didn't have before. And you might say, well, that's a lot more complexity, but I don't actually think so, because it's a lot more. It's actually, in a way, it's actually clearer. The things like which values are optional, all these things, which constraints, like the optional stuff, it's right in your face. The constraints, we have this thing called a string 50. We have a thing called an email. So again, it's right in your face. We now have these, we've separated out the name from the email address so they can be updated independently. And this domain logic about whether it's unverified and verified is much clearer than it was before. It's much more self-documenting. If I'm a new developer and I come onto your team, I can look at this stuff and figure out what it's doing. So the language is evolving with the design. I actually think this is a better domain model than the first one because it actually expresses the domain. Just like with the shuffle card, the shuffle deck is different from a normal deck. A verified email is different from a normal email, and we've actually represented that now. And of course, this is compilable code, just to re-emphasize that. And in Eric's book, he has a chapter called Refactoring Towards Deeper Insight. And what happens when you start doing this modeling is you actually learn things about the domain. And as you learn things, it gives you insight. It's like, oh, I realize there's a whole bunch. Now that I've got this new concept called a verified email, it's like, oh, I see all sorts of other places where I can use it. So we might have a business rule that says you can only send password resets to people with verified emails. Now, in the previous version, we'd have to check the Boolean flag, and it's like, is it allowed? In this version, we just say a function that sends a password reset, and the input is a verified email. We do not have to check the flag. Again, I cannot get this wrong, because the only way I can call this function is with a verified email. The only way I can get a verified email is through the verification service. So, this concept of a verified email, you might find it popping up all over the place. So, right, part 4. Encoding business rules with types. So here is our contact, but this has got a new field in it. It's evolved. We have an address field now. So not just an email, but an address. And we also have, just typically, business says we have some new business rules. You have to have an email or a postal address. Okay, that's our new business rule. Now, this design does not meet that rule because as it stands, they're both required. Everything's required until we say it's optional. So this design doesn't work. Okay, well, I make them both optional. Well, this design doesn't work either because they could both be missing, right? So that doesn't meet the requirements. Now, you could say, well, I'll let them both be missing, and somewhere else I'll have some validation logic that checks if they're both missing and throws an error. No, we're not going to do it that way, right? So there's a great quote from Yaron Minsky, and it says, make illegal states unrepresentable. So if there's something you don't want somebody to do, don't even allow it to compile. Don't say, I'll let it compile, then I'll have some validation. No, don't even make it possible. So if you think about this rule, it says, if you have an email or a postal address, one of the two, is you have email address only or postal address only or both. Now notice I use the word or, right? That's the tip. There's 3 possibilities with an or between them. So here's the, you should be pretty expert at this now. We're going to model it with 3 choices. It's an email address, email only type, email only choice, or an address only choice, or a both choice. And and then we create this new thing. We stick it back in our contact. So what's nice about this is you cannot make a mistake. You can't accidentally have them both missing. And not only that, it's nice documenting code. If I'm a new developer on your team and I say, what the various combinations, you say, well, I don't even have to ask you. I can look at the code and say, oh, there's 3 possible combinations. So that's very nice. So we've encoded the requirements in the type system. We do not have to write a unit test for this because it literally will not compile. So this is how awesome composable types, not quite as awesome as a cat on a unicorn, but almost as awesome as that. Now, the final thing I want to say, and I'm going to stop in a minute or two, communication is a 2-way street. And as developers, it's okay to push back to the business. And you know, this requirement is actually pretty ugly, because you might say, well, if we have a new kind of way of contacting you, you're going to get a combinatorial explosion, and there's going to be 20 different kinds of, you know, that's probably not what we want. So how about this? You know, a contact must have at least one way of being contacted, rather than, you know. It's not exactly the same, but if you go back to the business, yeah, actually that's fine. Yes, that's a much better, from a developer point of view and from a modeling point of view, it's much easier. Because we can say, well, here's the way we have a contacting you. We can contact you by email or address. And then the contact, there's a primary contact and a secondary contact. And the primary contact is required, and the secondary contact is optional. And that is very clear from this domain. And what's nice about this is these choices can be expanded, right? So we can say, you know, we can evolve the design very easily. If you need to be contacted by Facebook or text or, you know, Twitter or whatever. So it's much easier to extend this design model. So that is everything I want to tell you today. Let me just summarize what we did. We used code to represent the shared mental model and the ubiquitous language. You didn't put it in a documentation. We didn't do UML diagrams. We used executable code. And, you know, this is not big design up front. We're not trying to get the perfect design on day one. You know, designs evolve. As you learn things about the domain, you learn new stuff. And you want the design to evolve. Change is going to happen. You should embrace it. And this is this refactoring towards deeper insight that I was talking about. And one of the nice things about using a statically typed programming language for this is it gives you the confidence to make these changes. Like if I change the verification, verified email, the rest of my code will break. And that's a good thing, because I've changed the kind of model. All my code will break, and typically in functional programming what you do is you make that change, and then you spend an hour or two chasing down all the red squigglies, fixing up all the compiler errors. But once the compiler errors go away, you have very high confidence that you've actually fixed all the issues. And that's not necessarily something that would be true in like a dynamic language. So composable type systems are really powerful. I highly recommend you look at them, because we're using choices rather than inheritance. We're using options instead of null. We've got these nice little one-line wrappers for these constrained types, and we can actually make illegal states unrepresentable. We can actually encode some of the business rules in the domain model. Not everyone, like the rules of poker, you can't encode in types, but you can go a long way to at least getting the big concepts down and having a shared mental model. So, if you like this talk, I have the slides and the video will be on my website. I've got a lot more videos on my website. I have a whole book. If you like this, if you think this is interesting, my book is all about this. If you want to contact me on Twitter, it's got Wlaschin. And thank you very much.